the problem of captive dependencies is actually very easy to understand, because all it's about is how components depend on other components and their lifetimes. So essentially, a captive dependency is a situation where a long-lived component holds on to a short-lived component. So let's try to engineer such a scenario. Now what I'm going to do is I'm going to use the fact that whenever you have an IEnumerable of something, then orderFac will inject all of the descendants of that IEnumerable into the type. So let's try and build something like the following. I'm going to define an interface called iResource, and then I'm going to define a class called Resource Manager. Now inside the Resource Manager class, what I'm going to have is I'll have a public property which is going to be an IEnumerable of iResource. Okay, so I'm going to have this IEnumerable of iResource called resources, like so, get and set, and then of course I'll build a constructor for it. So let's do C-P to make the initializing constructor. So we have this interface and we might have certain descendants. Now I'm going to make two descendants here, and one of those is going to be a singleton resource. So that would be a resource that would just be constructed once and then used anywhere, and a different resource would be a resource that's done on an instance per dependency basis. So whenever you need it, a new instance is constructed. So let's call this instance per dependency, and let's not forget that it's an iResource. iResource. Okay, now here's the thing. When you initialize a resource manager, when you actually create it from the container, what's going to happen is orderFac will try to populate the resources list with an instance of each component, which might seem okay, except that only one of those is a singleton. So the singleton resource is going to live throughout the entire application, and that's fine. It's going to be populated here, but the instance per dependency, to have it exist in this particular location, is not great. Let's actually build out the rest of the example, which is fairly predictable. So we'll have a container builder, new container builder, there we go, and then of course we register the resource manager first of all. So builder.register type resource manager. So the resource manager is going to be a singleton, and also the the singleton resource is going to be a singleton as well. So we'll builder.register type singleton. Singleton resource is going to be single instance as well, but the other resource, the instance per dependency, is not going to be a singleton. Instance per dependency, actually we should probably rename it, like instance per dependency resource is a better name. Resource, there we go. Okay, so instance per dependency resource is just going to be created whenever you need it. So the scenario is something like the following. You have the container, where you just do builder.build, like so, and then maybe a scope of some kind using var scope equals container.create begin lifetime scope, and then inside the scope you do scope.resolve resource manager. There we go. Okay, so let's talk about what's happening here. You're resolving a resource manager, which is itself a singleton. That's okay. That's totally fine. It also happens to hold a reference to the instance per dependency rule, because what happens is when you populate the IEnumerable, you end up with an instance of a singleton resource in here, which is okay because they are both singletons, so they live throughout the entire lifetime of the application. But you also drag in an instance per dependency resource. So the outcome of this is as follows. You have something which is per instance, but unfortunately, because it's a dependency of a singleton, it ends up being created and dragged throughout the lifetime of the entire application, whereas it's explicitly an instance per dependency, or maybe not explicitly, but the way you've configured it, it's an instance per dependency. I can actually add in a few constructors and destructors here just so that you can see that it is in fact created and destroyed. So let's have a constructor where we'll just write line instance per dependency created, and then we'll do an IEnumerable like this, IEnumerable, no, iDisposable. Sorry, we need an iDisposable. So generate a dispose, and here we'll console.writeLine the fact that an instance per dependency is destroyed. Okay, so if I execute this now, both of these will unfortunately be called. So let's actually run the entire program. Okay, that didn't go according to plan. Let's see what went wrong here. So we have these iResource, and of course, the problem here is that when we've registered the types for singleton resource and instance per dependency, they're not registered as iResource, so therefore they're not injected. So we need to add as iResource here, and the same goes for the other one. So we'll just copy this over and add here as well. Okay, so let's go again and let's see those two things get invoked. Okay, so now you can see that instance per dependency is created and destroyed, and its lifetime is actually tied to the lifetime of resource manager, which is a singleton. And this is an explanation of what captive dependencies are. So it's not the end of the world. You can live with captive dependencies, but you have to realize that the operations which you might have intended to work in the way that you specified as you were configuring the builder, they might have been subverted somewhat, because you're expecting this instance per dependency to only be created whenever somebody needs it, and you want it to be destroyed essentially whenever somebody has no more need of it. But because resource manager is a singleton, it ends up keeping track or keeping hold of an instance of this component throughout its entire lifetime, which may or may not be what you want.